All right, let's continue. Now this one I need to do a little bit of work before I can take the integral. I need to FOIL the x plus 1. It's a binomial squared, so I don't have a way right now to take the derivative of something in that form, or sorry, the integral of something in that form. I am going to FOIL it out until it looks like something I'm able to work with. Next, I'm going to distribute the 1 over x. X, that's with respect to x. Okay, now it looks like something I'm familiar with. I can take the antiderivative of this expression. So the integral of x is x squared over 2, right? So you add 1 to the power, and then you divide by that number. The integral of a constant, such as 2, we learned just above, that you get 2 times x. And now the integral of 1 over x is brand new. So you might say, well, let's write that as x to the minus 1 power. That would be logical. And then you're saying, well, according to the rules, you add 1 to the power, and then you divide by that power, right? Okay, so what would happen if you did that? If you added 1 to the power, you get 0. Negative 1 plus 1 equals 0. And then you divide by 0, but that doesn't make any sense because that's not allowed. So that process does not work on taking the derivative of 1 over x, antiderivative of 1 over x. And so we need a process that's going to give us that for our answer. And so think about a function, we'll call it h. All right? Give me a function h so that when I take the derivative of h, I get 1 over x. So what kind of function would that need to look like? The derivative of h equals 1 over x. It actually kind of looks like the answer, don't you think? So you understand that we learned that the derivative of the natural log of x equals 1 over x. And so the antiderivative of 1 over x is the natural log of x. Probably a bad choice of letter. Let me make that this, okay? So I'm trying to figure out what kind of function h do I need to have in order for its derivative to be 1 over x. That's the idea. So if you think about it, you understand that the natural log of x has a derivative that's equal to 1 over x. Now we need to specify that I'm only allowed to use positive values for x. X is an absolute value, and so you have to put absolute values around that x. You're not allowed to use anything you want to. X has to stay greater than 0. And then, of course, don't forget your constant, plus c. The next one is an exponential function. All right, here's what I'm going to do. I'm going to first bring this 4 into the front so it doesn't get into my way. And now I need to figure out how to take the antiderivative of e to the 3x. Well, think back about taking the derivative of e to the 3x. How is that done? The derivative of e to a power is e to the power times the derivative of the power. All right. Well, the opposite, that's the antiderivative of e to a power, is e to the power divided by the derivative of the power, okay? So this is going to say 4 times e to the 3x divided by 3 and plus c. Or you could write this as 4/3 e to the 3x plus c. And we'll go ahead and check this one since we haven't checked one for a while. We're going to call this g. All right, that's my family of functions, g, because it's got that plus c in there. So if I take the derivative of g, here it is, I'm going to check. What's the derivative of g? Well, let's see. The derivative of e to a power is e to a power times the derivative of the power. But don't forget that we had a times 4/3 in front of that. So let's give us some space here. Let's just do it like this. I'm going to put the 4/3 where it was supposed to be, times the derivative of the power, and then you simplify and you get 4 times e to the 3x. So we've got it, we've checked it, it's right. Okay, so the antiderivative of e to a power is e to the power divided by the derivative of the power. Number 6, we have to rearrange, simplify a little bit, play around with it till it looks like something you're able to handle. So why don't we go ahead and write that as two separate fractions. So 1 over x to the fourth minus 2x squared over x to the fourth. No big deal. I can write each part of the numerator divided by that one denominator each time. And I'm going to, I don't know, change that into an x to the minus fourth. That would make more sense. Over here, 2 of those cancels with 2 of those. So what is that? 2x to the negative 2. This is all with respect to x, just in case you're keeping track. And so now the process says taking the antiderivative of x to a power is where you have added 1 to the power and divided by that power. And the antiderivative of negative 2, x to the negative 2, is negative 2x to the add 1 to the power, divide by that power. There's your constant. I write this as maybe negative 1/3 x to the negative 3 plus 2 x to the negative 1 plus c. Perfectly acceptable if you want to, if you don't mind having negatives in your exponents. Don't forget your plus c. All right, another example. Let's do this piece by piece. I don't need to rearrange anything. I'm just going to leave it like that. So the integral or the antiderivative of 40e to a power is 40 to the power divided by the derivative of the power. Okay. Next, we have 5 over x. The antiderivative of 5 over x is 5 times the natural log of the absolute value of x. The antiderivative of negative 3x squared is negative 3x, add 1 to the power, divide by the power, and then plus 1x, and plus c. And change the way this looks. How about negative 400 e to the negative 0.1x plus 5 natural log of x minus x cubed plus x plus c. That's what you get. Number 8. So same exact process given to you in a different form. This is a differential equation. We are going to solve for y, where y is a function of x, if we know that dy dx equals that expression. We are furthermore told that when y equals negative 2, x equals 1, we'll use that at the end. You'll see how. So first thing I'm going to do is I'm going to rewrite dy dx as dy equal to 1 over x minus 2 over x squared times dx. So do you see that I just multiplied both sides by dx? Now I want to solve for y, don't I? I have to get rid of the d. The d is your differential. You're going to take the integral of both sides. Taking the antiderivative, this is the antiderivative of the derivative, cancels each other out, and now you just have y. So y equals the antiderivative of 1 over x minus 2 over x squared with respect to x. And so let's go this way. I am going to get the natural log of x minus 2. Let's see. Think of this, I should have written this out first, but I didn't. Think of this as 2x to the minus 2. Okay, so there's a minus here. Okay, so minus 2, x to the minus 1 over minus 1. Then there's your plus c. So let's change this to, how about plus 2 over x plus c, just for something different. All right, next you're going to utilize the fact that when y equals negative 2, x equals 1, and that pertains back to your function f of x. All right, so that is for f of x. It's kind of sloppy. But basically this is telling you that f of 1 equals negative 2. All right, and so if f of 1 equals negative 2, take your answer that you have so far and set it equal to the y value, negative 2. So we have negative 2 equals, put 1 in for the x, natural log of 1 plus 2 over 1 plus c, right? And so natural log of 1, if you need to use a calculator, you can, but you're going to get 0. And we're going to solve for c. We subtract 2, we get c equals negative 4. And this now is going to allow you to replace the constant c, the general constant, with what it's supposed to equal. So we are going to subtract 4, and that will give you your exact answer. All right, question number 9 is very similar to what we've been doing, phrased in a little bit different way. If each point xy on a curve, y equals f of x. The slope is f prime, okay? The slope f prime gives you the instantaneous rate of change of your function f at any value of x. Find f of x, the general function, if the point 0,6 is on that curve. So 0,6 is going to be used at the very end of our process. So if we want to find f of x, that means we want to take the antiderivative of f prime, don't we? So the antiderivative of f prime of x is going to give you f of x, right? That's the idea. And so that means we want to take the antiderivative, or the integral of 3x squared plus 6x minus 2 with respect to x, of course. And so piece by piece, we get the antiderivative to be 3x cubed over 3 plus 6x squared over 2 minus 2x plus c. There's that constant. All right, now we're going to use the fact that the point 0,6 is on the graph of f of x, right? So that means when x equals 0, y equals 6. So take that expression that you just found and set it equal to 6. 6 equals, and then plug in, I should have simplified, but I didn't. Sorry. Plug in 0 for x, plug in 0 for x, so it looks something like this. And you're going to find c from this, aren't you? You're going to get c is equal to 6. And so that means you're allowed to write your exact answer, your antiderivative of f prime, or f of x rather. This is what you're going to write. F of x is equal to x cubed plus 3x squared minus 2x plus, not c this time, because we just found out that for this particular graph, c is equal to 6.